Hi, this is Paul from Forza Tech. In this video, we are going to deal with the indeterminate power using L'Hopital's rule, which is the last objective in this section. Let's see the outline. First, I will introduce a strategy which we can use to evaluate the indeterminate power through L'Hopital's rule. Then we will practice two questions together about how to use the strategy. Let's see the material. Here is indeterminate power. Suppose we have two functions f and g. Can you see this composite function is the base is f, the power is g. Okay, and this kind of power we have three types. All the three types are indeterminate. Okay, let's see the first. If f approaches 0 and the power g also approaches 0, which means the type is 0 raised to the 0's power. Okay, this is indeterminate. The second, if f approaches infinity, the power g approaches 0, which means infinity raised to the 0's power, and is also indeterminate. The last term, if f approaches 1, g approaches infinity, which is 1 raised to infinity's power. Okay, this time we still cannot determine. Okay, it's still indeterminate. And you see, now we have a big trouble. How to evaluate? Okay, and because f and g are, you can say it's completely separate, right? So we cannot put them together easily. We need a strategy. And the big trick is here. We have to change the base. At the first one, f is a base. We do not like a function go to the base. Okay, and we change the base to e, a constant number. Can you see how do you change? Of course, we use the inverse rule, right? And then we change the base. If we change the base, now everything goes easy. Let me highlight this most important trick, like here. So the big one is change base. Okay, and this is the major trick. And after we change the base, now what do we have? We have power of power rule, right? So gx times ln fx. Can you see what do we have? We have a single base e constant number. The new power is put f and g together. Okay, so this is what? This is a exponential function. Now exponential function is continuous, right? So we use the continuity. The limit can goes up to the exponent, which means we have this form. Now you see what do we get? We get 0 times infinity, or infinity times 0, which is indeterminate product. Okay, we learned this in the last video, right? Okay, if we have this, then we have everything. And what do you do now? And we just change the product to quotient, and then we can use L'Hopital's rule. See, and let me highlight this first. The first we come to here, and this time is indeterminate product. Okay, so if we go to here, everything is clear, right? Let me explain a little bit why this is 0 times infinity or infinity times 0. Okay, no matter which type, let me pick the first type. Let me verify one by one. And if f approaches 0, g approaches 0. See, g approaches 0, so this is 0, right? F approaches 0, this is what? Infinity. You can say negative infinity, whatever. So it's 0 times infinity, right? The second, if f approaches infinity, g approaches 0. See, g still approaches 0, right? If f approaches infinity, so ln infinity goes to infinity. What does it mean? We still have 0 times infinity, right? The last type, if f approaches 1 and g approaches infinity, see, if f approaches 1, ln at 1 is 0. See, this approaches 0. The first term, gx approaches infinity, is still 0 times infinity. So hope this makes sense, right? no matter which type, if we follow this strategy, we always can go to the indeterminate product, which means we can solve the question. Now, let's practice this strategy. Here is the first question, and we have a limit of power. Let's check first what's the type. Okay, and let me see. So the base, which is what? 1 plus 0, right? Which is 1. So what? The base is 1. What is the power? 1 over 0. Of course, it goes to infinity, right? Can you see? That exactly belongs to the type we discussed just. Now, what do we do? Change base, right? The big idea is change base. So we are going to change base. So we do this. We're going to change base and see what do we get. So we're going to change base. I guess suppose it's 0. We change it to E, right? So this is the easiest. And then the power goes to 1 over x, right? If you remember. And then take ln and the parentheses. So 1 plus sine at 3x. Let me put the parentheses, okay, like this. What do we get? So we already get a kind of exponential function, right? Now what we can do? We can use the continuity, okay, of the exponential function. So we have a continuity, okay. Then the power can go to the limit can go to the power. See, so what do we get? We get e raised to the limit. Okay, then is 1 over x, right, times ln and the parenthesis 1 plus sine 3x. Let me copy. Okay, so now we have a limit of a product. Let's check the type. And the first 1 over x is infinity. So the type is this time is infinity times 1 plus 0, which is 1. L1 is what? 0. Okay, so this product is 0 times infinity, which means the indeterminate form, right? What do we do? Change this product to quotient, right? So our basic strategy. Change it to quotient. Which quotient we can change? Of course, the easiest the quotient, which is directly put the x to the denominator. Can you see? Okay, so we have this. Put the x to here, so we have ln parenthesis 1 plus sine 3x. Right? Okay, so now we have a quotient. Let's check again. This quotient, of course, this time you see is 0 over 0. What do we do? Log p as a rule, right? So now we finally go to log p as a rule. Okay. So we need to take a derivative. Okay, we're going to take a derivative. So what do we have? Okay, and the x take derivative is 1, so I just ignore. And then we need to take a derivative of the numerator, which is a composite function. We need to use a chain rule. Okay, we're going to use a chain rule to get. What do we have this time? Okay, ln u, which is a u reciprocal, right? Reciprocal is this. U is a 1 plus sine at 3x. Okay, and the derivative of the inner, which is what? Which is a sine. You know, it's still a chain. Okay, the second time use chain. Is not a sine. Sine take a derivative is a cosine, right? So I have to change. This is a cosine. Okay, and don't forget 3x is another inner. We need to times this 3 again. See, and then we finally take the derivative. Now what do we get? See, easy. Directly substitute that. So cosine at 0, this is 1, right? Okay, sine at 0, this is 0. See, so we have the results now. What the results is e raised to 3 over 1, which is 3. Okay, so this is the result. Now let's practice one more question. Here is the last question, and see we have a power. Okay, so the first let's check what the type. So the base of course goes to what? The base goes to 0, and the power of course approaches 0 again. Can you see? 0 raised to the 0th power. This is an indeterminate form, right? Okay, so now what do we do? And the bigger the idea we still okay, change base. Let's change base. Okay, so I will going to change base. Okay, so see what I get. I will get this. I will get the limit x approaches 0 positive on the right side, and the base we put the e. Okay, and then we have a square root of x times ln at x, right? And now what do we have? We have a exponential function, right? Use a continuity. As the last question, what we did, we use a continuity. Okay, we put the limit to the power. Okay, so now we have this. I guess approaches 0 on the right side, and then the limit is square root of x times ln x. Okay, you know what do we have? We have a product. Let's check the type. Square root of x approaches 0, so the type is 0 times ln approaches 0 goes to infinity. See, that's infinity, right? So we have this type, that's indeterminate. What do we do? Change it to a quotient, right? So we did it in the last video. We're going to change it into quotient. So e is still here, and the limit. So let's change it to a quotient. Now we have a question. And either put the square root of x to the bottom or ln x to the bottom. Which one is easy, do you think? Okay, of course, the first term. Why? The first term is a power. We put the power to a power function. But the power function to the denominator is still a power. It's just a negative, right? If you put the ln x, it will be very complicated. Okay, so let's do this. So we leave an x to the top. So the bottom, now I change it to this form. X raised to the negative 1/2 power. Is this true? Yes, okay. Now we check it again. You will find, and now the type is infinity over infinity, which means what? Okay, which means this is L'Hopital's rule, right? So we are going to use L'Hopital's rule now. Okay. Take the derivative. So we're going to take the derivative. So e is here, and the limit x approaches 0 from the right, and then is a fraction. Okay, we take a derivative to the top, which is 1/2, right? As a reciprocal, right? So 1 over x, and then we take a derivative to the top, to the bottom, which is a power function, and you know the rule is take the power down, right? And the times the new power is the old minus 1, which is a negative 3 over 2, right? And now what do we have? We have this kind of fraction. Simplify, don't worry, okay, simplify. We're going to simplify, see what do we have now. Okay, we have easily. So can you see negative 1/2 to the bottom, take to the top, which is negative 2, right? So negative 2 per here. And at the top is x raised to the negative 1's power. This quotient, negative 1 minus negative 1.5, which means plus 1.5. What do we have? We have positive 0.5, which is 1/2. So x raised to the 1/2 is a square root, right? So let me just put the square root of x here. Okay, so look, it's much simple now. And then we can directly substitute, right? See, per log 0, so this 0. And then so the new power, now the power or exponent is just goes to 0. Okay, so the answer is 1. We finally get. And then just go through some steps. Okay, so this is the answer. That's all. Thank you. I hope you enjoy learning on this topic. If you have any question, please leave your comment. If you like this video, please give me a thumbs up. Thank you for your support. Please don't forget, you are very welcome to subscribe to my channel for more videos. In the next video, let's see, we will move to section 4.5, summary of curve sketching. Hope to see you there. Thank you. Have a nice day. Bye.